talking about experiment 2 in p-chem today, and this is particle on a ring. And instead of a perfect ring, we are going to be looking at conjugated systems like benzene and naphthalene and extensions thereof, where we add more and more six-membered rings. And so, in one sense, the hexagon can be approximated, benzene can be approximated by a circle. And then we can also look around the perimeters. So we can approximate higher order things as, let's go around the perimeter on the external thing. So this is a circle for benzene, a perimeter for naphthalene, and then as we go to the higher order ones, we'll have perimeters like so. And so these can be approximated as particle on a ring systems. So the pi electrons are the particles, and the cyclic conjugated perimeters are the rings. And so what we'll be doing is measuring the electronic spectra of progressively larger ring-type systems and seeing if we can develop a correlation between the quantum mechanics of particle on a ring and its energy levels and the size of these rings, something that we can follow experimentally in the laboratory. Now let's take a look at today's lab sheet. So this is experiment 2, chemistry 432. So if you'll get your lab sheet out, we'll talk. We won't go through all the derivation. When you do your lab report, you'll do that for me. Okay. So the first few equations on the page, in fact, equations 1 through 5, summarize the situation for particle in a box, assuming just one electron is involved. And if you turn to equation 6, you'll find that the end result of all this analysis is that the wavelength of the light that induces a transition from one quantum state to the other is proportional to the length of the linear box squared. Now, a similar analysis for particle in a ring, which we started and quickly went through in class earlier today, we found, go to equation 12, that the wavelength of the light is proportional to c squared, where c is the circumference of the ring. And by the way, the circumference equals the carbon-carbon distance between adjacent carbons times the number of carbons around the ring minus 1. So you can see the obvious parallel between particle in a box and particle in a ring, and we're going to look at these systems now and see if we can get a correlation. Now, our focus will be looking at a relationship between n squared and c, the circumference of the ring, and lambda and c squared. We've gotten beautiful results in previous years, and I have no doubt that today you're going to have another very successful lab experiment, just like you did for the linear case in last week's lab. So at this point, the next step is to go to the stockroom, to go to the labs and find these molecules and measure their spectra.